Hypothesis testing, a subtopic where your teacher gives you a lot of practice, but you do not know what the hell you are doing. Don't worry. Today, I will guide you through the idea and concept of hypothesis testing. In this video, I will mainly focus on the explanation rather than the calculations. Before the video started, I assume that you have already known the basics and the calculations of the hypothesis testing, but do not understand what are you doing. Okay, let's get started. First, what is testing? Testing for what? We perform testing is to test for assumptions. The steps of a hypothesis testing are very similar to the flow of our thoughts in daily life, but it is in a mathematical perspective and it quantifies or assigning a value to some observation. I will first be explaining the steps of the flow of the thought so that you will have an idea on what you are doing. The first concept that we need to know is extreme and surprise. I will use an example to explain this. Just now in the short video, at first, Tom thinks that the size of the mouse is very small, let's say about 10 cm. So he assumes that the size of the mouse is as small as Jerry. But once the second and the third mouse comes out, because their sizes are way too big, it has already out of Tom's expectation. Therefore, these sizes are very extreme in Tom's perspective. Then Tom will be surprised. Why surprised? Because relative to our assumption, this situation is very unlikely to occur. It has a very low probability. So, at that time, Tom decides to reject his assumption on the size of the mouse is 10 cm. We can say, under Tom's assumption, Tom is very surprised because he observed something very extreme from what he expected. So Tom decides to reject his assumption on the size of the mouse is 10 cm. Then what if the size of the mouse is just a little larger than Jerry? Let's say 15 cm. This size isn't very extreme because it is within the range of expectation. So Tom will not be surprised after seeing this. Therefore, in this situation, Tom will not reject his assumption. He will still be thinking that the size of the mouse is around 10 cm. In short, when you observe something that is out of your expectation, you will be surprised. Then you decide to reject your original assumption. Why do I use the word decide? It is because we do not know about the truth. Is the size of the mouse really about the same size as Jerry? It may be possible that there is a big mouse like this. It may also be possible that the size of the mouse won't be this big. It may just be an elephant pretending to be a mouse. Okay, now, let us summarize the flow. At first, you will have a thought or an assumption. Then you will be observing something. If the thing that you observe is very extreme, it is out of your expectation, then you will be surprised. When you are surprised, you will then decide to reject your original assumption. If the thing that you observe is not extreme, it is expected to be happen, then you will not be surprised. Naturally, you will not reject your original assumption. Let us take a look at another example. In this picture, we have two places in a classroom. a place for student A and a place for student B. And there's a correction tape on the floor. If no one is in the classroom, and you can't ask anyone, if I ask you, this correction tape belongs to whom? Is it belongs to student A or student B? What do you think? You may pause the video and think, after that can play back the video. Okay, you may think that the correction tape belongs to student B because the distance is closer to student B's table. What if we don't talk about student B, we just talk about student A? Since the correction tape is very far away from student A's table, so you would think that the correction tape does not belong to A. Okay, if we look from the perspective of hypothesis testing, what will it be? At first, we will have two assumptions. The first assumption is the null hypothesis, which is this correction tape belongs to A. We also have an alternative hypothesis which opposes the first assumption, which is this correction tape does not belong to A. If the correction tape leaves student A's table that far, relative to H0, this distance is considered as extreme. So you will be surprised. Huh? If I say this correction tape belongs to A, really? Will that be? Then you will decide to reject H0 and conclude that the correction tape does not belong to A. Does that really mean that this correction tape doesn't belong to student A? The answer is, don't know, because we will never know what the truth is. Huh? Then why do we perform testing? My thought is, although hypothesis testing cannot tell us the truth, but because we have a statistical evidence, we have a reason, so it is worth to refer. Okay, come, let us take a look at another situation. How about this far? Huh? This distance is that extreme. If I say correction tape belongs to A, is that possible? Then you will reject H0. Then how about this? Huh? Of course reject H0 lah. How about now? Relative to H0 assumption, this distance is not extreme at all, so you will not be surprised. So do not reject H0. How about this far? Should I reject or do not reject H0 leh? Then the question comes, how far it is to be considered as extreme? So in mathematics, we need to provide a quantification to give a value, a number, to describe the distance and to describe how far is the distance so that H0 will be rejected. That is why we need alpha, the significance level, and test statistic value. When we have an alpha, we can find the critical value, that is, the value that considered as extreme, and compare it with the test statistics. So in hypothesis testing, you will have two hypotheses. You will have H0 parameters equals to some value, and alternative hypothesis H1 which opposing your H0. We can set the alpha, the significance level, equals to how much? Generally, we will set at 5%. Then we identify the statistic. Think about what statistic can be used. We will also have a formula or a function for the test statistics under H0. When we have a function, this implies that we also have a distribution. Under this distribution, use alpha to find the critical value, meaning to find what value will be considered as extreme. After that, we observe something to find out the test statistics value. Then we see where the test statistic is located in the distribution and compare it with the critical value within the distribution. If the test statistic value is over the critical value, then the test statistic value will be considered as extreme. After that, we were surprised of seeing something extreme. Then we will decide to reject H0. Otherwise, if the test statistic value does not over the critical value, then it will be not extreme and not be surprised. Then we decide not to reject H0. In the end, you can make your own conclusion. And that's all for today. If you find this video helpful, please hit the like, share, and subscribe button. Thank you. Bye.